Hello friends, welcome to online course on non-conventional machining or advanced machining processes. As already we have discussed the working principle of abrasive water jet machining as well as setup for abrasive water jet machining. Today we will cover the remaining part of this topic, that is abrasive water jet machining. In this lecture we are going to cover the process parameters as well as parametric analysis for abrasive water jet machining, and then we will discuss the effects of process parameters on performance of abrasive water jet machining. So let us start with the process parameters for the abrasive water jet machining. So here I have shown fishbone diagram for the abrasive water jet machining, that is AWJM. Now first of all we have the water. Okay, water is the one process parameter. Here the pressure of the water and the flow rate of the water, both are the parameters for this particular process. And then there is a water nozzle. Okay, materials of the water nozzle is important as we have seen already, and the cross section of the water nozzle, that is also important parameter, and it can have a circular cross section or it can have rectangular cross section also. Then we have the hardness of the material is a very important parameter. Other material properties are also equally important. Then workpiece material, whether it is brittle or ductile, that will decide the material removal rate and the mechanism of material removal. Okay, so these are the process parameters. Also we have abrasive particle size. Okay, what is the absolute size or mesh size of the abrasive particle, that is also important, whether they are coarse or they are fine, and the type of abrasive particles, whether it is silicon carbide or alumina or other type of abrasive, is also important to know. Okay, then we have the flow rate of the abrasive, that is also another important parameter. Then abrasive feed nozzle, what are the cross section of the abrasive feed nozzle and the material of the feed nozzle, that is also important, because it is not very hard, this abrasive nozzle, then nozzle itself will wear out and you cannot control accurately the abrasive feed rate. So that purpose we should consider the abrasive feed nozzle. Then there are the cutting parameters like feed rate, number of passes, angle of cutting, and standoff distance or nozzle tip distance. So there are the cutting parameters which affect the performance of this abrasive water jet cutting process or abrasive water jet machining process. And the mixing tube parameter, in that again mixing tube diameter and the length of the mixing tube, both are important parameters. Okay, and the output responses which are normally measured and based on which the performance of abrasive water process is evaluated, these are machining rate, that is MRR, then quality of cut edges, then curve quality, and the depth of cut. So these are the output responses. Okay, now let us discuss the effect of pressure on depth of cut. As you can see here in this particular figure, here is a point which is written as critical pressure. This is the minimum pressure unless the kinetic energy of abrasive particle crosses that is the critical pressure, it cannot penetrate inside the workpiece surface, and that is why you can see there is no cutting in this particular zone. That is the point before the critical pressure is reached. Okay, and as the abrasive flow rate is increasing, the depth of cut also increasing. Okay, as you can see here also, but beyond a certain limit or beyond a certain pressure, this is not a linear relation, This is a non-linear relationship and it tries to stabilize beyond a certain pressure. Okay, beyond a certain pressure, it goes to stabilization. Okay, and if you see here, as abrasive flow rate increases, depth of cut also increases. Again, this is also not a linear. So you can see here the minimum pressure or the critical pressure or kinetic abrasive particles needed to cut material is there, and it is difficult for it is different for different workpiece. Okay, so through this diagram we will get the effect of abrasive water jet pressure on the depth of cut. Okay, now same things is given here also again as a explanation. As already I have mentioned, below the critical pressure no cutting will be takes place, and it that means the critical pressure is different for the different workpiece materials. It depends on the workpiece properties. Above a definite jet pressure, machine depth tends to stabilize. Okay, and the relationship with the machine depth is steeper with the higher abrasive flow rate. Increased pressure will lead to higher cost of pump maintenance, because if the pressure is very high, then the maintenance of the pump becomes more expensive because of more wear and tear, and it gives lower efficiency at very high pressure and higher nozzle wear rate also observed with a very high pressure. Below the critical pressure, the stress in developed in the workpiece is lower than the yield stress. That is why you do not get any removal of metal below that. Okay, so here, okay, it shows the effect of water jet pressure on the depth of cut. Okay, you can see in this diagram. Now if you see here, this water jet pressure initially increases, and afterwards, by increasing this water jet pressure, initially depth of cut also increase, and afterwards it tries to stabilize. Now you can see here that is nozzle diameter D1, okay, and D2. If nozzle diameter is increase or larger, then depth of cut also decrease. Okay, also decrease, as you can see over there. Okay, I repeat, if nozzle diameter is larger, then depth of cut also decreases, as you can see over there. Okay, it is because if the same power, that is a pump motor, is there, then the pressure of the water, abrasive water jet coming out, is lower, and that is why the depth of cut is also smaller. Okay, if you see here, water flow rate means water is propelling fluid that enables high abrasive flow rate, and the flow rate you can have is a high as 5 kilogram per minute. Abrasive velocity normally it is kept 300 meter per second, and abrasive water jet is coherent, hence more suitable for cutting, and this is much more coherent as compared to the abrasive jet machining process. Now you can see here, the water flow rate is directly proportional to the under root of the pressure, and it is directly proportional to the square of the diameter of the nozzle, that is dn square. Okay, now the machining depth is proportional to velocity of abrasive particles as well as the mass flow rate. Okay, machining depth is proportional to the velocity of the abrasive particles as well as the mass flow rate of the abrasive particles, that you can see here. And above the critical value, mass flow rate of the abrasive particles, above the critical pressure of the mass flow rate of abrasive particles, the depth of cut start reducing, and increasing mass flow rate leads the wear of the mixing nozzle, and higher wear of the mixing nozzle leads to reduce the mixing efficiency, and that is why there is always appropriate or critical amount or critical value of the mass flow rate of the abrasive particles. Selection of the type of abrasive. Selection of the type of the abrasive depends on the cost of abrasives, nozzle wear rate, then environmental considerations and machining rate. Finally, it also affects the particle strength. Okay, so let us see the effect of abrasive flow rate. As you can see here, the abrasive flow rate is increasing, the depth of cut is increasing in the different kind of the abrasives, say glass bead, then silica sand or alumina. Now one thing we can see here in the is that depending upon the type of abrasive, the depth of cut is different in different cases. Okay, now abrasive particle size, and there is always an optimal particle size for the particular application, which include the workpiece material also, and fine abrasive particles are good for shallow depth of cut, and the coarse particles are good for high depth of cut, and different abrasive size for a different depth of cut are also proposed by some of the researchers. However, in practical or in practice, it seems to be little difficult task, and the machining rate or machine depth is function of the type of the abrasive. This is also mentioned by the researcher. Okay, now let us discuss the next process parameter, that is a traverse speed. This traverse speed is a relative motion between the abrasive water jet and the workpiece. It can be achieved by moving the abrasive water jet or workpiece. If you see the relationship between the traverse rate and depth of cut, this is a kind of the relation that you can obtain. As the traverse rate increases, depth of cut decreases. Okay, and if you see here in this diagram, as the traverse rate increasing, the area generation rate is increasing. There is an optimum area generation, and beyond which it start decreasing. Okay, now the depth of cut decreases with the increasing traverse rate, which may be within the 10 mm per second. Okay, so this is about the traverse rate. Okay, herewith we have finished with the process parameters and its effect on the performance of abrasive water jet machining, and this is a reference which I have referred for the my lecture. Okay, thank you very much.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends, and don't forget to subscribe to our channel. After subscription, you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.